CD Foundation Governing Board and a member of the CNCF Governing Board as well, as an author of multiple books, especially in the Java development space. I have the personal privilege of calling Steve boss on a daily basis, and he truly is an amazing mentor for his team. So today, Steve's going to be talking about scaling DevOps to the edge. So looking forward to that. And without any further ado, I'm going to turn it over to you, Steve. Thanks for joining us.
Cool. Thanks very much for the very warm welcome, Ari. It's great that I'm able to speak at this event. It's actually been a while since I got to travel to India. So this is my virtual trip.
Awesome.
Okay, and what I'm going to talk today about is a little bit about taking DevOps all the way to the edge of your deployment. So how you can scale and efficiently distribute and deploy applications to different edge devices. So as Ari mentioned, I'm VP of Developer Relations at JFrog. You can catch me on Twitter at SteveOnJava. So feel free to reach out on Twitter if you want to say hi. And I think we've all been playing this game for a while with working from home. But somehow when the whole pandemic started, I imagined things would be very different. So I figured that we might be like vigilantes, kind of like this, roaming the freeways, trying to forage for food with our trusty dog. Actually, as it turns out, a lot of people got pets during the pandemic, myself included. But I got a cat instead of a dog, or my kids got a cat instead of a dog. So that was a little bit different. And the other big difference is I think a lot of us ended up with a setup which looks a lot more like this than something more out there. So it's great, and I think it's awesome that as developers we're able to work from home and we can stay safe and productive while working remotely. And if anything, I think the situation has caused companies to realize that it's even more important to support remote workers and remote conferences like the one we're in. So I think it's made it much more accessible for getting technology across the world and to a much wider audience, and also create a bunch of opportunities for developers to do things. And if you're anything like me, you probably have increased the number of IoT devices in your house over the past year. Maybe you even have security cameras, or you have smart plugs, or smart heaters, or other IoT devices in your house. And this is in general a global trend which is occurring with the move to the edge, the move where you have lots of internet connected devices that need software updates and need to be supported. So according to Gartner and Statista, by the year 2020, so we're already there, 20.4 billion devices and 31 billion IoT devices will be online. So that's a lot of devices. And if you look at it, it's things like smartphones. So I think we all have smartphones. Actually, smartphones have taken over even computer usage. The amount of internet traffic produced by smartphones has exceeded the amount of internet traffic produced by desktop computers. Smart TVs, smart fridges, and smart cars. If you don't have a smart car, I think we're all kind of envious of folks who do have smart cars. And smart cars in particular is an area and an industry where people are really pushing forward and making huge advances. So according to the Volkswagen CEO, they expect the software to make up 90% of the auto industry innovation. So I think all of the different car manufacturers looking at software and software releases as the path forward. So this is one of the examples of an industry where they are pushing things to the edge. They are deploying to devices, and they're creating fleets of devices which are electrified, so electric cars, autonomous, shared, and connected. And this is everything from smart cars to smart trucks to smart farm equipment, and the sort of use cases which they need to be able to account for when you're looking at supporting global deployments of smart cars are things like autonomous driving, so the cars know how to navigate by themselves. Fleet management, so you can know exactly how many of different vehicles which you have out there, know when failures are going to occur, when you need to replace them. A lot of electric cars have very advanced battery technology, which they're constantly improving the software algorithms to improve the efficiency of them. Different sensors, especially if you're doing autonomous driving, but also for farm equipment, so you can measure moisture, humidity, and different things to improve your yield. Navigation and infotainment for consumer devices, automotive AI, communication systems so that you can communicate to the devices even when they're remote. Regulation tracking. One of the big things is for shipping and other industries, they need to be able to make sure that they're carefully tracking where things are going and the path from farm to table of all the devices or all the cargo which they're carrying. So this is another big concern for companies which do trucking and shipping. Carbon footprint data, so that you know how much you're offsetting or increasing your cost as a company. Safety and security, and shared vehicle enablement. So there's a lot of use cases for this. And by the year 2030, it's expected that the connected vehicle market is going to be a 14 billion ecosystem. So this is a huge market. It's expected there will be 146 million connected vehicles in the US alone, 470 globally, and 15% of the vehicles sold will be autonomous. 30 to 50% of vehicles sold will have an electric drivetrain, and shared vehicles will increase by 40%. You can already see this with things like the California legislation that mandates that all cars sold must be electric. I think it was by the year 2030. So they're even pushing this from a government and a regulation standpoint. Okay, so if you see this trend coming, where we're pushing to more edge devices, to more connected devices, how do we get software to all of these devices? How do we do software distribution to all of these devices? And if you look at it, there's a general physics problem with software distribution as you go to edge devices. So if you're used to working with cloud computers and data centers, and even on-prem data centers or other environments, typically you have very fat bandwidth. You have the ability to transfer large amounts of data, transfer large Docker images, and do rapid deployments. But as you push to the edge, the fire hose becomes more of a drip, because essentially what you're deploying to are devices on networks which are slow, which are less reliable, and which give you a lot of constraints. And besides the general network issues, which is improving with technologies like 5G, you also have the issue of the one-to-many problem, where you have a small number of servers deploying to a very, very large number of devices. So again, you're splitting your bandwidth and your ability to deploy quickly over a very large network of devices. So just breaking down this problem, the first problem is rapid development. So if you look at the speed of development and change, over 520 million new apps and services are going to be released by the year 2024. So with all of these applications and releases being produced, it requires that you have the ability to deploy quickly to the edge as well. The second big constraint is deployment frequency. So how quickly you're pushing devices or deployments to the edge. And over 60% of enterprises are deploying to prod daily or faster by the year 2025. So if you're still doing releases which are monthly or weekly, or even a couple times a week, this is something which is required by security issues, zero-day exploits, and in general customer requirements for having faster delivery. That you'll be shipping software faster, you'll be shipping software more often, and therefore you'll be shipping a lot more releases. The third part of the problem is the explosion of infrastructure at the edge. And if you look at this, we have a lot more devices which are coming on, and over 50% of new infrastructure is going to be deployed at the edge by the year 2023. So this exponential growth in infrastructure basically forces having better solutions to the deployment problem. Okay, and the last part of the equation is compounded artifacts. And there's 7 million edge locations and over 38 billion things predicted by the year 2021. And this is continuing to rise exponentially. So as the number of devices continues to increase, this requires that we have better solutions for distributing artifacts. And if you look at who's consuming these artifacts, who's actually the recipient of the artifacts, you have a bunch of different folks who are the recipients. So one of them is just getting your internal repositories to developers. The second one is external repositories, so pushing artifacts which are going to be consumed by different companies or by consumers. And over 60% of the Global 2000 are going to have third-party developer ecosystems, generating 20% of the revenue. So exposing artifacts externally to other companies is also a big use case. And the biggest use case is now machines, where you need to now push your releases to the edge with runtime environments which support this edge distribution. And I think if today you're primarily deploying releases internally in your company to Kubernetes clusters, or possibly starting to deploy releases to partners and other ecosystems, this drive and push towards the edge will strain your current release bandwidth for doing distribution. Okay, and then some of the bottlenecks to consumption of releases are development teams. So basically your ability to quickly deploy and produce new releases. So if you're following an agile process, if you're doing things quickly, then you can more quickly release your software. Operations, so your ability to have cloud native environments set up to deploy quickly, to have a lot of automation on the side, on the DevOps area. So the fact that you're here at a conference talking about DevOps and security and how to improve the speed of agility will help you to deliver more quickly and achieve this scale. The third bottleneck is the runtime environment. So making sure that you actually have a global distribution network so you can quickly deploy. And then finally, getting things to the edge and all of the end users. So if you're scaling effectively, you can reduce your development productivity time and by increasing your cycle time. You can increase your release velocity, and that decreases your risk. You can do global distribution at scale, and you can also do better customer acquisition and retention by getting things to customers more quickly. So this helps solve the problem of scale for your company. And there's a few different ways which you can accelerate your distribution of releases to the edge. So one approach is to do distribution via edge nodes, where essentially you're standing up instances closer to the edge devices. And those edges are the ones that are going to be deploying to the edge devices rather than your main artifact repository. The second one is you can rely on content delivery networks. So using CDN distribution, you can increase your ability to deliver static artifacts. You can't be quite as smart about what you're delivering, but as long as the artifacts which you're delivering are static files, then this can also help to speed up delivery to a global network. And the last one, which is the most flexible, is peer-to-peer download. So this gives you the ability to not only to deploy to the edge devices, but to have geographically co-located nodes which are closer to your edge devices, where you can have peer-to-peer sharing and higher velocity to quickly distribute. So let's go back to the automotive use case and how you can set up an environment which is going to allow you to accomplish this use case to deploy to cars more quickly. So let's say you have your CI/CD system set up using a CI/CD system like Jenkins or JFrog pipelines. This would push releases into an artifact management system like JFrog Artifactory. And the JFrog platform also includes a distribution solution. And what distribution does is it allows you to push to Artifactory edge servers, to content delivery networks, and to hybrid environments. So this allows you to set up instances which are physically closer to the devices you're going to be deploying to achieve that scale by setting up multiple different edge nodes or content delivery network nodes, and then quickly push releases down to devices so that you can more effectively release and distribute. Now let's talk a little bit about how you could do the same thing with a peer-to-peer topology. So let's say instead you're deploying in a data center to a Kubernetes cluster. And one of the problems with deploying to large Kubernetes clusters is that especially for large Docker images, the Docker image push in the data center network actually competes with itself when you push it to multiple nodes simultaneously. And you see huge spikes in response time for pushing large images down. So you can do this with the same sort of setup, right? Using Artifactory for storing your releases. Artifactory acts as a container registry. You can check your security and compliance with JFrog X-Ray, and X-Ray will dig into container images, kind of peel the onion layers apart, and then do security scanning of those vulnerabilities, which are matched against hashes in our known vulnerability database. So it flags any known vulnerabilities. Then you push it to distribution, and then this goes out to a network of devices. Now, in this case, rather than it being pushed to each of the individual Kubernetes nodes individually, they're set up in a peer-to-peer configuration, and as it's being pushed, a la BitTorrent, they're sharing the information with each other. And what this does is this improves the reliability and the speed of the network. So this shows you the response time with peer-to-peer technology and without peer-to-peer technology. And you can see that if you're pushing a large set of data to a large set of nodes, then the network suffers a lot of degradation, even inside of a data center when you're pushing to a Kubernetes cluster, because you're competing with yourself on bandwidth within the network, and you're not getting efficient throughput through the network to get your releases pushed quickly. With the peer-to-peer technology, this evens it out because now all of the nodes are sharing data with each other. So this helps you to achieve kind of constant performance and have a much more robust implementation for pushing releases. So this is an example of how the peer-to-peer burst technology works. And you're breaking the responsibility of serving a package between Artifactory and the CDN. So it's being split between those two. The initial download served by Artifactory, and then it gets pushed to a content delivery network. Artifactory, the edge node, does the content resolution to figure out what the right package is and determine which artifacts need to be served. And then it's the CDN which actually serves the artifacts. You can configure the CDN by repository for which you're going to put in the content delivery network. And you can deploy this either with on-prem or on the cloud to quickly push out releases using this technology. And even for very large Docker images, which are 85 gigabytes or larger, this combination of CDN plus peer-to-peer on each pod communicating with each other gives you the best distribution performance possible. And one of the things which we just announced at the SwampUp conference, which just happened, is in addition to our peer-to-peer technologies and our edge nodes, we also have a new private distribution network, which makes this even easier to set up with a self-configuring mesh of peer-to-peer nodes. So that makes it even easier to achieve this scale with very lightweight peer-to-peer nodes. Okay, so putting this all together in terms of how the JFrog platform helps to solve the edge distribution use case. So everything upstream from source control, you can use your favorite Git system for. Do your builds with JFrog pipelines, push it into Artifactory for storage, do security scanning with X-Ray. You can also have a lot of visibility with mission control and oversight, and finally push it to production using distribution and edge nodes, which work on-prem, work multi-cloud, and also allow you to push to CDNs and take advantage of peer-to-peer technologies. Okay, so the bottom line is you can achieve faster downloads, improve developer productivity, faster time to production, and be able to distribute internally and externally faster using this technology. This gives you scalability, so you can manage spikes of concurrent downloads and distribution. So it helps you achieve that scale as we get to hundreds of billions of devices. Your network will actually be able to handle all of that large load in a peer-to-peer fashion. You're improving the performance and the network utilization and the resiliency of your system. So this improves the uptime of your overall system. And this is a proven technology which we've been building and using with our enterprise customers for quite a while now. So I hope this was informative, learning a little bit about the ecosystem for edge devices, some of the challenges with pushing to large Kubernetes clusters or to devices where you have to push things to a large portion of edge nodes, and how you can apply peer-to-peer technologies to this problem set to improve the performance and ability of your network to be able to handle the load. So feel free to ask any questions you have about kind of these use cases, about the technologies, and also something else which I'm working on is a new book about DevOps tools for developers. So if you have any questions in general about source code, CI/CD, about kind of how you can build microservice architectures or how you can deploy, I'm also happy to talk about and answer questions along those lines.